The need for faster, more powerful, and more efficient computing capabilities has been growing, yet engineering and materials issues have been making attempts to scale performance difficult. However, that could be changing thanks to recent developments in silicon fabrication processes. A team of engineers from MIT has created a new process that deposits 3-atom-thick, atomically thin transistors printed on top of existing chip circuits, growing, high-density, high-performance computing stacks. 2D transition metal dichalcogenide (TMD) materials serve as the base of this novel approach, allowing for greater density and performance enhancements. At the core of the process is molybdenum disulfide, which is composed of molybdenum with 2 sulfide atoms, only 3 atoms in total. This material offers great electrical and photonic conductivity, making it an ideal option for semiconductor transistors. Since temperatures need to be kept relatively low to ensure the security of the underlying circuits, the new fabrication process uses dual chemical vapor deposition with different temperatures in its 2 chambers. The molybdenum stays in the low temperature area while the sulfur passes through the higher temp area, decomposing and reacting with the molybdenum for TMD deposition. This is the first time that transistors have been grown in a single continuous layer across an entire chip or wafer, which also means that aligning the layer to the existing circuit is no longer a problem. The MIT scientists managed to create a high level of uniformity and quality for their 8-inch wafer, improving the chances for the process to be used for manufacturing purposes. Indeed, the use of this process could expand beyond current chip design and be applied to polymers, textiles, or even paper, making it possible to apply computing capabilities to things like notebooks, clothing, and other applications. Overall, the work done by the MIT engineers has made great strides in improving the efficiency of chip fabrication and looks to be a real game changer in the computing industry.